The Fermi Paradox poses a profound mystery at the heart of modern astronomy and philosophy. In a universe teeming with billions of stars and even more planets, the odds suggest that intelligent life should be widespread. Yet, despite decades of searching, we have found no clear evidence of alien civilizations. This contradiction between the high likelihood of extraterrestrial life and the overwhelming silence we observe raises unsettling questions. Why, in such an immense cosmos, does humanity appear to be alone? The Fermi Paradox challenges our understanding of life, technology, and the very nature of existence beyond Earth. The Fermi Paradox traces its origins to a simple yet profound question posed by physicist Enrico Fermi in the 1950s. Where is everybody? During a casual lunchtime conversation, Fermi wondered why, given the immense size and age of the universe, we have not yet encountered evidence of extraterrestrial civilizations. This question sparked decades of scientific inquiry, challenging researchers to reconcile the high probability of life elsewhere with the lack of observable contact. The paradox is underscored by the mathematical odds against humanity being alone, as calculated by the Drake equation. With hundreds of billions of stars in our galaxy and countless galaxies beyond, the sheer numbers suggest that intelligent life should be common. Yet, the silence persists, making the Fermi Paradox one of the most intriguing mysteries in astronomy and astrobiology. The rare Earth hypothesis proposes that intelligent life is exceptionally uncommon in the universe, largely because Earth possesses a combination of rare and favorable conditions. Factors such as a stable climate, a protective magnetic field, and the presence of a large moon have all contributed to the development of complex life on our planet. According to this hypothesis, these circumstances may be so improbable that intelligent life elsewhere is exceedingly unlikely. This perspective invites us to consider the possibility that our existence is a cosmic anomaly, a unique outcome in an otherwise inhospitable universe. If true, it would mean that humanity occupies a singular position, shaped by a series of fortunate events that may never be replicated. The implications of this idea challenge our assumptions about life beyond Earth and underscore the preciousness of our own existence. The Great Filter is a thought-provoking concept that seeks to explain why, despite the vastness of the universe, we have yet to encounter evidence of advanced extraterrestrial civilizations. According to this idea, while life may emerge frequently, most civilizations face significant barriers that prevent them from surviving long enough to explore or colonize the stars. These obstacles could include self-destruction through war, environmental collapse, or other catastrophic events. The Great Filter suggests that somewhere along the path from simple life to spacefaring societies, there is a stage that is extremely difficult to pass. As a result, many civilizations may disappear before they ever reach the capability for interstellar communication or travel. This concept raises profound questions about our own future and the challenges humanity may face on its journey beyond Earth. The zoo hypothesis offers a fascinating perspective on why humanity has yet to encounter evidence of extraterrestrial life. According to this idea, advanced civilizations may be deliberately avoiding contact with Earth, choosing instead to observe us from a distance. Much like animals in a nature reserve, humans could be under the watchful eyes of cosmic observers who wish not to interfere with our natural development. This approach would allow these civilizations to study our behaviors, cultures, and technological progress without influencing our trajectory. The hypothesis suggests that the lack of contact is intentional, preserving our isolation until we reach a certain level of advancement or readiness. While there is no direct evidence to support this theory, it remains a compelling explanation for the silence in our search for intelligent life beyond Earth. Detecting signals from alien civilizations is an immense challenge, largely due to the overwhelming background noise present throughout the cosmos. Radio waves, cosmic rays, and natural phenomena all contribute to a complex tapestry of signals, that can easily obscure or mimic artificial transmissions. Our current technology, while advanced, is limited in both sensitivity and the range of frequencies it can monitor. There is also the possibility that extraterrestrial messages could be encoded in patterns or formats that are unfamiliar to us, making them indistinguishable from random noise. As a result, meaningful communications may be hidden in data we have already collected, waiting for new analytical techniques or breakthroughs in understanding. The search for alien signals is as much about expanding our technological capabilities as it is about broadening our perspective on what constitutes a message. The dark forest theory presents a striking perspective on the nature of the universe and the behavior of advanced civilizations. According to this idea, the cosmos resembles a vast, shadowy forest, where each civilization acts like a cautious hunter, remaining silent to avoid attracting attention. The fear is that any signal or sign of existence could invite danger from unknown entities. In this scenario, survival depends on secrecy, as revealing oneself might lead to catastrophic consequences. The theory suggests that the apparent silence in the universe is not due to a lack of life, but rather a collective strategy of self-preservation. Civilizations, aware of the risks, choose to hide rather than communicate, shaping the universe into a place of quiet tension and uncertainty. Throughout history, there have been numerous claims suggesting that extraterrestrial beings may have already visited Earth. Ancient myths from various cultures often describe encounters with mysterious visitors from the skies, leading some to speculate about alien contact. Unexplained artifacts, such as the Antikythera mechanism or the enigmatic Nazca lines, continue to puzzle researchers and fuel theories of advanced non-human intervention. Similarly, the construction of massive structures like the pyramids and Stonehenge has prompted questions about whether ancient civilizations received help from otherworldly sources. However, the evidence remains inconclusive, and many experts argue that these phenomena can be attributed to human ingenuity, creativity, or misinterpretation. The line between genuine encounters and the products of imagination is often blurred, leaving the question of alien visitation open to debate and further investigation. The simulation hypothesis proposes a radical idea that our universe might be a sophisticated digital construct, created and maintained by an advanced intelligence. According to this theory, everything we perceive, including the laws of physics and the fabric of reality itself, could be the result of programmed code. Within such a simulated environment, the emergence and proliferation of intelligent civilizations could be intentionally restricted by design. This built-in limitation would help explain the Great Silence, the puzzling absence of detectable extraterrestrial life. If true, it suggests that our search for other civilizations may be futile, as the simulation's parameters simply do not allow for their existence or contact. The hypothesis challenges our understanding of reality and offers a unique perspective on why the universe appears so quiet. Humanity has long been captivated by the possibility of life beyond Earth. Across the globe, scientists have launched ambitious programs dedicated to searching for extraterrestrial signals, employing powerful radio telescopes and advanced observation techniques. Projects like SETI scan the skies for patterns that might indicate intelligent communication, while missions such as Voyager carry interstellar messages intended for distant civilizations. Despite decades of searching and no definitive evidence yet, our determination remains unwavering. Each new technological advancement brings hope that we may one day break the cosmic silence. This relentless pursuit reflects both our curiosity and our desire to connect with something greater than ourselves. It is possible that the silence we encounter in the cosmos is not evidence of emptiness, but rather a reflection of our own youth as a civilization. Humanity may be among the first to develop the technology and curiosity needed to reach out across the vast expanse of space. If this is the case, our search for others is only at its earliest stage. The universe is ancient, and civilizations may emerge at different times, separated by millions, or even billions of years. As pioneers, we might be the first to send messages into the cosmic void, awaiting a reply that could take generations to arrive. The quiet we perceive now could simply mean that the story of interstellar communication has only just begun.